Hello! In this video, we'll recreate the Linux ls command in Rust. How many times have you typed ls today? This command is a staple of the Linux command line that lists files in the current directory. We'll build our own version with Rust's safety and speed features. We'll call our version RLS, our rusty take on the ls command. Let's start by creating a new project using cargo new. For the directory name, we'll use ls in Rust, but for the cargo package metadata, we'll set the name to RLS. We can put all our logic into the main rs file. No need to split this into many different files. Everything we need is in the standard library. Specifically, we'll import env for command line arguments, fs for file system operations, path for robust path handling, and process for clean exits with error codes. We'll keep the standard function signature for main. Our first step is to grab the command line arguments using env args collect. Let's add a quick debug print to see what we have, then run cargo run. Notice we get exactly one argument, the path to the binary. During cargo run, cargo compiles and then executes the binary from the target directory. If we run it again directly, you'll notice a second argument appears. This small difference gives us a foundation for parsing flags. Next, let's determine the target directory. If the user provides an argument, we'll use it. Otherwise, we'll default to the current working directory, just like the real ls command. We'll use path new from the path module to wrap that string slice in a path object, which is safer and more ergonomic for working with paths. Now it's time to read the directory contents. We'll use fs read dir to do the heavy lifting using the path we just built. We'll match on the result. If it succeeds, we iterate over each entry. For every entry, we'll extract the file name. We could just unwrap this and force an error if there's an issue with the file name. But in reality, the ls command replaces weird characters and handles strange file names, doing its best to display them anyway. We can copy this behavior using the toString lossy method on our file name. Of course, we also need to prepare for error cases. We'll print an informative error message like could not read directory entry, and then show the error details. But wait, we also need to handle the situation where we can't open the directory at all. That's a completely different type of error. So for each file, we might encounter errors reading entries, but we might also face errors at the directory level. For this category, let's match the error. If we get a not found error, we should print a specific message. We may also want to handle the permission denied case explicitly. And finally, let's catch all other errors with a general fallback. Now we have a good set of errors handled. And if we run into trouble, let's exit with an error code. Let's do another cargo run, and there it is. All the files in our current directory are listed perfectly. Let's make this more interesting. What if we install our binary in usr local bin? Now we can run our custom ls from anywhere. Try specifying a different directory. See what happens if you use a path with issues. The files show up. But if you try to list a directory that doesn't exist, we get a clear, descriptive error message. How cool is that? This alone is already a great starting point, but let's go further by adding some new features. We'll add a few more imports. Besides fs, let's also import dir entry. And while we're at the top, let's expand our argument parsing. Maybe we want to implement the show type indicator, a neat feature in the original ls, and also add sorting for the output. Let's define our target directory string as another argument, just as we tried before, and set up a variable to track whether the path argument was found. This makes our argument parsing more sophisticated. Let's start fresh with a for loop over our arguments. We'll skip the very first argument, that's just the binary name, nothing useful for us. Once we skip that, we want to monitor whether we found our path argument. What this really means, if we already have a path, then anything else in the CLI command should probably be avoided or trigger an error. That's how we'll handle it here. If someone runs ls source but then adds a random flag, we're going to insist that flags come first just to keep things simple. So let's add an error message, unexpected argument after path. We'll also print some usage information. It'll really help the next person who uses our command. Let's say we implement S and F flags. Then we exit with error code 1. Quick reminder, error codes matter. If our ls command tries to list a directory that doesn't exist, the exit code will be 1. For a valid directory, it's 0. That's important for Linux executables and CLI programs. Now we've got code checking if our path argument was found. We'll set that variable to true later, but let's handle the flags. Let's loop through the characters of the argument. We'll skip the first character, it's just the dash. Then match on the individual flags. If it's F, set our variable to enable the show type indicator. If it's S, we'll sort the output. If it's something else, let's report an unknown flag. Once again, if something goes wrong, we simply print the usage information. Our flags now set the right variables. They shape this run's behavior. If an argument isn't a flag, we'll treat it as the path. So let's point target dir at that value and set path arg found to true, telling the parser that's the last one, no more flags after this. We can safely remove the extra parsing code we had below. All that work is now at the top of our program. Building the target path and handling directory entries stays the same, but we need a place to store entries when S for sort is active. Let's create sorted entries. An empty vector we'll only use if sorting is requested. When sorting is turned on, we'll loop through each entry, but instead of printing right away, we'll push it into our sorted entries vector while still logging any read errors. Now for the fun part, sorting. We call sort by key and use entry file name as our key. After that, we loop through the sorted list and send each entry to a helper function called processEntry, keeping our main flow clean. If the user doesn't use S, we skip the vector entirely, just iterate, match, and process immediately. Why waste computing cycles? So far, so good. We still need that process entry function. It must decide whether to show the file type indicator, a neat ls feature. At the top of the function, we'll grab the raw file name and a lossy string version for safety, plus an indicator string. Remember what f does. A directory gets a backslash, a symlink gets an @ and a normal file gets nothing at all. We're going to skip executable checks because they're platform specific and beyond our scope today. If we can't read a file type, we'll print a quick warning and continue processing. Finally, we print the entry. We'll use curly braces for formatting, show the file name, and add the indicator at the end. Time to build our program. Oops, we have an error at line 27. Let's change it to flag char, save, and compile again. Now the Rust borrow checker is helping us out. We have a small issue with our borrow checking setup. Let's change this to a string type. And down in our else case, we'll do a clone. That should fix the build problem. I was a bit too quick with the edits. What we need to do is we have this string, we clone it, and in our path object, we need to get a and str from that string. So we'll create a reference to the string which fixes the error. Great, now we have a successful build. Let's install our program and try out some of the flags. For example, let's look at the target debug directory with sorting enabled. If we view it unsorted, we get things in a very different order. Let's also use the F flag to see which items are directories. Just for fun, let's create a symbolic link as well. And there's the indicator showing up exactly as expected. Let's try combining these flags. I'd say our program is working quite nicely. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all code in the description as well. If you have any questions, please post them in the comment section, and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy responsibly.